Hello, I'm Iwei. So today I'm going to briefly introduce our final project and also introduce how to use our web application. So our project is a Flask-based web application designed to emulate the functionality of Firebase. So our goal was to create a platform that offers a similar database structure and real-time data streaming compatibilities like Firebase. Our team used Python Flags framework for server-side coding and also HTML and CSS for client-side interface. And also we use MongoDB database to store and manage data. These web applications offer several core features, including supports for crew operations, like using the methods of put, get, post, delete, and patch on data collection. And also, our platform offers real-time updates for the data via WebSockets. So it can provide very similar experience like Firebase for the user. And then let me introduce the web applications that we develop. So it's called Waterbase. It's simply emulations for Firebase. Very simple. There is only a plus buttons on the left top corners. Click on that. We have key and values. So basically, you can create documents here. Let's say we have a study group. So, and we assign some initial values for the study group. Let's assign Eric, Jimmy, and Peters for the study group. And we click on add. And we successfully create a study group. And these are the documents ID. You can see that there's a name for students, Eric, Jimmy, and Peter. And now let's say we have some information about Eric. So we click on add, this plus buttons. Let's say we have his score, and it's, let's say 80, and we'll click on add. And we successfully add some more information for Eric. Same as Jimmy, let's say score 95, and it's the same. So Peter, let's say we don't have Peter's score. We have something else for Peter. So let's say we have a second name for Peter. Second name. And let's say Peter has another name called Tom. And we add. And so we cannot add Tom like this because the value has to be in JSON format. So we double code that and we successfully add a second name for Peter. And let's say we just found out that the second name for Peter is not Tom, it's actually something else. And we want to update this information. So we have to click on this plus button again, enter the same key here. And let's say Peter's another name is called Waterbase. Okay, and we click on add. We successfully update the second name for Peter's, so Waterbase. And finally, if you want to delete any data from here, simply click on this. And also, if you want to delete the whole document, that's also fine. And also, you can delete the whole study group. And this is our web application. It's very simple, nice to use, like Firebase. And that's it. Thank you.
So I'm gonna go over some technical details about our servers. So okay, so basically our server is implemented using Flask. So basically we implement two custom class first. We implement one called MongoDB, which is a class we use to connect with the MongoDB database. And then the second class we implemented was request info. So basically this class is used to store all information about the request made by the user. So basically we have couple variables. The first one is the root database, which is the database we used to store uh, all the data in MongoDB. And then the pass variable stores the required pass, and then the collection, which is the first level of of our pass, which is used as our collection in the database, and then the full pass is simply the full pass, and the data variable is the data in JSON format uploaded by the user. And then operators is a dictionary we use to store all the operations used request like order by, limit at first, limit at last, etc. And the keys is all the keys after the collection. And the .json is the variable we use to check the .json ending. Simply we just check the key if the key has the .json ending, or the collection has the .json ending. If they has the .json ending, we set is true, and then we basically split the full pass by question mark. Anything after the question mark will be our will be in our operators dictionary, uh, which we use the key as the we use the operation as the key, and then and anything after equal will be our value. So by using these cards, we don't have to worry about handling the request every time when we need to implement functions. So for our proof function, we first build our request info class, and we get the database from the request info and the collection, and also we check the JSON data. So if the data upload is not a JSON form, it's not in JSON format, we just return an arrow saying that it's not a value JSON. And then after that, we're gonna check our data. If our data is a list, it's gonna be mapped into our custom data format, which is ID and data. So basically, we have ID as our unique identifier for a document, and then we store any data after under the field data. So basically, by doing this, we can uh, enable a lot of query functions in MongoDB. And so if the if there's no request key, we're gonna just insert it. We're gonna just assume that the user want to insert this data into the collection. So we just drop drop the collection if it exists, and then we just insert all the data into that collection. So then we also check if there is a key. So if the number of keys equals 1, so we just match the ID with the key request, and then we insert the data. And after that, if the key is longer than 1, so we need to join the keys together. So basically, the first one will be data because it's our custom design. So we join the data with all the keys except the first one. So we use the first one to match the document, and then we change the data based on the joined key. So, and then anytime when user put any data into our database, we use WebSocket to send message to our clients. So the clients will have the real-time updates. Okay, so uh, Jiajing is gonna talk the other functions.
Hello, this is Xiaojin, and let me share my screen and I'm gonna talk about the remaining REST operations, including get, get, patch, host, and etc. So here it is our get function. So first of all, the get function, just like the put function before, we have to access the collection from the Mongo data, MongoDB, Mongo database. So here data collect is the collection that our data is at. The keys is also from the request info clause and representing the keys that the user type in the terminal for later search. The number of keys is the length of the keys. So just like before, if we check for if there is no operators, we check for the number of keys. If there is no number of keys, we will simply return the whole collections. So and with its projection of data and ID, if there is only one key, so we need to find the collection corresponding to key 0, which corresponding to that one key, and projection with data and ID as well. If there is more than one key, we have to join the keys just like before, and this time we have to find the key. We need to find the collections with the join key, where this is the command that we find the whole collection that we're looking for. There's another situation there that we have some operators and we want to check if our keys are greater than 0. If it is, then we have this pre-target variable representing the target and the join keys. Otherwise, there is only data. So if there exists operators, we have different kinds of operators. So for example, if there is order by, we have to create an index for order by as index in MongoDB will helps the user to search for data much faster than the one if they don't have index. So here, if we do not have the $, which corresponding to the dollar value and dollar key, we directly create the index for the target variable. Otherwise, if there is key, we simply put the target variable as ID. So when we want to order by key, when we want to use order by key, we create index on the target variable ID, and then we do the order by search, so which is going to be faster. However, if the target variable is $value, it has to be the create index command will have to be specified in a curl command. So if we want to use the order by $value, we should also type in the corresponding attributes in order to create a specific index for that attribute. So here we try to create an index to see if their index already exists. Otherwise, we drop the index and then recreate the index to make sure everything works fine, even if the index of that specific attribute is already created. So next, we collect our index info and look for the target variable index. If the index is already exists if the index already exists in our database, we will directly use the target variable. Otherwise, there is an error message that we return we need to add a key called the create index equals name at the end of our request in order to create such index. So apart from using order by, there will be also several commands that we will be using at the same time. For example, start at, end at, equal to, and limit to first, limit to last. All these are gonna be if these commands exist in our curl commands, we will use the pipeline to aggregate all of these commands together to make it as a MongoDB command, MongoDB curl commands. And here is the pipeline that we want to use at the end of the get method. So by using this pipeline, we can obtain the cursor, from the data collect that we're gonna use later for to provide the get result. Here we simply manipulate the data to be the form of a key and value pair in order to become a valid JSON object that we can add to the result later. So if there is no data, we just return there is no data found. Otherwise, we can just get the data with it just JSONified data and return it. The next method is post. So the difference between put and post is that the put method will override the whole object that we're assigning to it. But post command instead will create a new JSON object with a random key. So all the previous codes are the same, just like put. The difference is here we have n equals to 8 that we're gonna create an 8-bit an 8-byte random ladder for the random key that we're gonna use later. So next we check the number of keys. If it's 0, we're gonna use this to create a single object. So if there is no key, we just create a collection with a single JSON object with the random key. If there's one key, we use the set command in the Mongol query language, and we use the data plus res as the key. And then next we use update 1 for the post to create such new instance. Here we have to mention that the opposite is true, because if there is no such if there is already have such key, we will not be inserting it. But since the key is randomized as 8 bits, I don't think it is quite possible for it to be duplicate. So if there's more than one key, we use the join keys. Update 1's opposite is equals true. The last one is since post will have to modify the database, we will have to use the socket method to send the request to the client and reflect it on the front end. The next one is delete. So delete is simply checking the same thing. We check the number of keys, and last that we did the join, we check the if there is 0 keys, we drop the whole collection. Otherwise, we delete one. If there is more than one keys, we use the update 1. We're onset the data. Okay, so finally for delete as well, we need to emit the data to the client. So for patch, we're gonna use patch is also very similar to the put one, but instead of override, it's simply update 1. Simply update the data instead of like overwrite the data. Yeah, and at the end, it also have to emit the data into the client in order for later use. Okay, so we will let Dongling to explain the rest of the client implementations.
Okay, so basically for our client, our scripts will control all the elements for our client. So basically, we get the data from the server. So after we get the data from the server, we will create elements for the collection. So if there's like 2 collection, we will create 2 elements with their name, and one plus button and one delete button. So it's like it's right here. So it's where create the elements for such client. So for such collection. So basically, if you collect the show button, it will show the data beneath the beneath the collection. So basically, when you click the plus button, it's where it goes to the collection and look for all the data beneath it, and create another elements based on that data. So basically, it's right here. No, it's not here. Okay, so it's here. So when you show the data, it's where create new elements based on the data. Yes, I think our client is like dynamically creating and deleting elements based on users' interaction with the web user with the web application. Yes, I think that's it for our demo video, and thank you so much.
Thank you.
Thank you.